Hey Jesse, this is Instructor Zyder, and this is my response to some of the questions that you have here. Unfortunately, I left my the pen that I usually use when I'm making videos and my Bamboo tablet at home, and I'm out of town right now for the holidays. But I'm going to do the best that I can with just my computer and my mouse. So hopefully just being able to highlight and type things up will be enough for you to follow the work that I do in the examples. I wanted to start by going through the page that you sent me and talking about some of the examples and the work that you showed, and then I'll go over to the examples that you provided me and I'll go ahead and work through those. May end up doing those in a separate video. We'll see how long this one gets. So here we go. You listed a couple formulas for factoring, which are correct. There were a few things missing. With your first one here, you wanted to make sure and have an exponent of 2 on the outside there, and that may have just been a typo. And with the second one here, if you've got subtraction for your second term, then that means the inside of the parentheses would also end up having subtraction. And then you also identified the formula for difference of 2 squares, which is good because that pattern pops up all the time. So in your problem 1, I see that you identified the factors for your first term and the factors for your second term. And so you were correct in factoring out a w, and that would leave you with 9 minus w squared. And then after that you wrote, if I were factoring this problem normally, this answer would be accurate. And this is where I get slightly confused. I'm guessing this is the answer that you were intending to use for this original form. But the step that you took right here was correct to factor a w out of both of these terms since they do have a w in common. What's left over in the parentheses here matches your factoring pattern for difference of 2 squares. And that's because 9 is a perfect square number and then w squared is a perfect square number. So from this point you could take it further. You would still have a w out front, and then you would have 2 sets of parentheses, and in each one the first term would be the square root of 9, so we would have 3, and then the second term would be the square root of w squared, which is just w, and then your second set of parentheses would be 3 minus w, and that would be the final form of that example. So again, using that pattern of difference of 2 squares. For your next problem, this answer is incorrect because of the fact that if you were to redistribute this, you would end up with 2a squared plus 1a plus 3a. And in your original expression, the middle term did not have an a. So this one does not have a greatest common factor, and this is the type of problem that you would want to use the AC method for. And I think that one of the examples that you gave me is going to end up using the AC method, so I'll show you how to do it with that example. And with this last one here, again, you wouldn't be able to factor out an x from this expression because of the fact that the 2 doesn't have an x. You can only take out a greatest common factor if every single term in the expression is divisible by that factor. And I think that this would be another one. Yes, this would be another one that would use the AC method. And I know it's easy to overlook. I don't know if everybody always sees this part of the discussion post, but here in the directions for the problem on page 353, make sure you use the AC method regardless of what the book's directions say. So you definitely have to include that approach in your discussion post anyways. So again, I'll show you how to use that approach using one of the examples that you provided me. That's not where I wanted to go. Let's go back over here. Okay. Alright, so let me go ahead and switch over to those examples. I haven't been talking for too long now. I think we can include this all in one video. So we'll come over here. Alright, the first example that you gave me is a good polynomial to factor using factoring by grouping. And I immediately think that because of the fact that it's an expression that has an even number of terms, which means that I can go ahead and split it into 2 groups. So I'm going to look at the first 2 terms together. Oh, I don't want to highlight the whole thing. I want to highlight just part of it. Let's see if it'll let me do that. It will, sort of. Okay, we'll go with that. X to the third minus 2x squared, that's going to be my first group of terms, and I'm going to look at what greatest common factor just those two terms have. And then I'm going to do the same thing with my second group, negative 9x plus 18. I'm going to look at what greatest common factor just those two terms have. So looking at my first group, let me insert an equation here. And scoot that over. Okay, so x to the third minus 2x squared. I always look at coefficients first and then variables second. So coefficients would be 1 and 2. Those numbers don't have any greatest common factors. There's nothing that they're both divisible by other than 1, which I don't need to factor out. So then I'll move on to the variables. Both of them have at least one x. In fact, both of them have at least x squared. So I can factor in x squared out to the front. And that would leave me with x minus 2. And I know that because if I do x squared times x, that would give me a result of x to the third. And then x squared times negative 2 would give me negative 2x squared. So that's what just my first group looks like factored. Now I'm going to move on to my second group. Now the thing with factoring by grouping is that you want the groups to match. Otherwise, the method of factoring by grouping doesn't take us any further. So what I want to end up with my parentheses over here needs to be x minus 2. I'm going to use the same approach. I'm going to look at the coefficients first. We've got negative 9, and then we have a constant of 18. And both of those numbers are divisible by 9. I'm going to go ahead and factor out the negative as well, so that this addition here will change to subtraction. And I know I want to do that because I have subtraction within my group over here. So if I factor out a negative 9, on the inside of the parentheses, that will leave me with x minus 2. So negative 9 times x would get me negative 9x. Negative 9 times negative 2 will get me positive 18. Now I have a situation where the factors within my parentheses match. And so I can factor out the common linear factor of x minus 2. And so if I did that, then factoring out the x minus 2 leaves behind with my first set of terms right here. It's a different there. We get no, don't highlight the whole thing. Okay, just with those two terms there, if I factor out x minus 2, then it leaves me with x squared. And with the second group, if I factor out x minus 2, then it leaves me with minus 9. So now this is written in factored form, but I'm not quite finished yet. You always want to check to make sure it's fully factored. In this case, it's not, because x squared minus 9 follows the pattern of the difference of two squares. So one more equation. I still want my x minus 2 in the front. X squared minus 9 factors to x minus 3, x plus 3. And it doesn't matter what order you could write that in. I could have also written x plus 3, x minus 3, and that would be okay. So that is the final answer of your first example that you've given me. You can always check to see if these are correct by picking a value for x and plugging it into the original equation and then plugging it into the factored, sorry, not equation, expression, and seeing if they give you the same result. I don't know if you have a graphing calculator a lot, but there's some really quick ways to check on the graphing calculator as well. Let me pull that up real quick here. Okay, I've got my graphing calculator pulled up here, and how I check to make sure that my factored forms are correct is I go to the y equals, I type in my original expression, x to the third minus 2x squared minus 9x plus 18, x to the third minus 2x squared minus 9x plus 18. And then I type in the second equation, my factored form. X minus 2 in parentheses, x minus 3 in parentheses, and x plus 3 in parentheses. And now I will push second graph and take a look at my table, and you can see the values in y1 and y2 match, and that's because those two things represent the same expression. They're just different forms of the same thing. So if you have a graphing calculator handy, then that's just one trick that you can use to make sure that your answers are correct. Otherwise, you can always just go in, pick a random value for x. For example, you could choose 4, plug that into the original expression, into the factored expression, and both of them should give you a result of 14. Okay. I'm going to go ahead and pause this video here so that these files don't get too large, and I'll work out your other 3 examples in part 2.